Hello students. So today we'll talk about cumene process, an industrial process to prepare phenol as well as acetone. So guys, when we talk about any industrial process, our primary objective is profit, because whenever industry get involved in any process, then the things become all about profit. So for any industrial process, for any manufacturing process, we are actually converting less expensive molecules or things into the more expensive or more valuable products. So here we are using benzene and propene, and we will convert this into, first of all, this thing which is known as cumene. And then this cumene will get converted into phenol and acetone, the more expensive one. And that is why this is an industrial process. Industry is always interested in getting more valuable or more expensive things from the less expensive one. Okay. So now let's move forward. How we can convert benzene into cumene. Our primary objective is this. This thing is known as cumene, the isopropyl benzene or 2-phenyl propane, whatever. So now, initially, we use H3PO4, pretty good acid, and this acid will provide H+. And as we can see that we will have a more electron density at this point. This electron density wants one H+ towards itself. Now, the problem is, this is something pretty similar to what we have observed in electrophilic addition reactions, Markovnikov addition for say. So we will get an intermediate, which is this, a carbocation. And my dear student, I always used to say that in organic chemistry, you generally encounter that reactions are acid-base reaction. All reactions are acid-base reaction. So we, on one hand, we have this benzene, which is nucleophilic in nature, and we have this electrophilic substance. So they will come together, join together to give us this cumene. Now you might say that, sir, is there any other process by which we can get this cumene? Yes, you all pretty well know about Friedel-Crafts alkylation reactions. So we can use Friedel-Crafts reaction. Now, in that case, we will use anhydrous AlCl3, a Lewis acid. And in this case, we're actually using an H+ donor acid. Arrhenius concept, or what you can say Bronsted-Lowry, because proton donor is this. So we need Lewis acid in this case. Now we all know that we will get the same structure or the cumene with this method also. Fine. So once we will get this cumene, this is our cumene. We oxidizes it in presence of atmospheric oxygen, another inexpensive substance, and we will get, first we'll get this one. This thing is known as cumene hydro peroxide, as it is evident that we have this peroxide linkage. And finally, this cumene hydroperoxide rearranges itself. This is known as Hawkes rearrangement. And we will get a phenol and acetone. Fine. So in a simple way, we can write that the cumene process can be simply written as at a slightly raised temperature. Fine. This is what cumene process is. Now let's talk about the mechanism. Once we got that cumene, what happens next? This is our cumene. Now, my dear students, a slightly elevated temperature or a raised temperature, what we can say, the oxygen will behave as this. And this will work as a free radical initiator for the continuation of the process. We can use some other free radical initiator. And as we can see that this hydrogen, this one, the benzylic hydrogen is more, you can say, furnishable, because what it will lead, let's make it like this. This is CH3, this is CH3, benzylic free radical, which is more stable. Okay, this is more stable, this is more liable to form. And then it's pretty easy, this oxygen form a bond with this. Fine, my dear students. So it's very easy to understand this concept, and we'll get this. And finally, this oxygen will acquire one hydrogen from the acids, acidic hydrogen which are available. So we will get the acidic hydrogen, means the hydrogen from the other cumene, because we have so many cumene molecules. So again, this benzylic hydrogen can be, taken by this oxygen, and we'll have another free radical prepare for the continuation of the process. So now what we actually get, we get this one. The cumene hydroperoxide, the cumene hydroperoxide. Let me revise this once again. This is my cumene. Just a second. Do we have anything which can be used for? Yes. This is my cumene. Fine. This is my cumene. By using this atmospheric oxygen, what actually we are doing, we are extracting this hydrogen, which is predominantly pretty liable to get, extracted. And why is it so? What happened? What happened? What is wrong with this? Why get stuck? So this H can be easily can be taken out by this, and we will get this free radical, the benzylic free radical, and then it will combine with this oxygen, which is again in the form of free radical. And what we'll get, this thing, and this will remove hydrogen from the other cumene molecule to form another benzylic free radical, which can pursue with the reaction forward. So we'll get this cumene hydroperoxide. Now what next? As we all know that we have certain hydrogen H plus available. This H plus can easily attack on the lone pairs of this oxygen. So what we will get? Look at this carefully. OH2 plus. Fine. OH2 plus. Now what's next? After forming this OH2 plus, oxygen can break this bond, and plus can be taken up by this oxygen. Here, what's the things start becoming interesting. As this oxygen will try to acquire this one, this oxygen will try to acquire the positive charge which is left over by this H2O. We can observe a rearrangement the positive will be taken over by this carbon, and one of these three will be migrated on this oxonium sort of ion. Fine, because O plus is there. Remember that carbocation rearrangement, this is exactly taking place in this scenario. And as we all know, that phenyl has a better migrating attitude than methyl. So what we will get? Removal of water take place simultaneously with the movement of this phenyl to this. So my dear students, we will get this now. CH3 plus O. Find the rearrangement. Now, this sort of rearrangement is known as, comes under the heading of Hawkes rearrangement. Okay, I will write it about Hawkes rearrangement. Just wait a minute. Now, the water which is coming out rearranges itself again to cover up this positive charge. So now what we can observe? That is, this water is coming out to place to cover up this positive charge. Now, as it is quite evident that oxygen will not ready to acquire this positive charge, then what will happen next? One of this positive ion, hydrogen ion, will get attracted towards this, again a sort of rearrangement, intramolecular. These two will exist in equilibrium. So let's rewrite it in a way so that it is easy to understand. And this H plus will be attracted towards this oxygen, the lone pair of this oxygen. What will happen next? This will acquire a positive charge. Any atom which formed a bond more than of its valency will definitely acquire a positive charge. What will happen next? This oxygen, as this oxygen is not ready to accept this plus charge, this plus charge will be donated by this oxygen to this carbon. And this bond will be like this. H plus will again released so that to start the process all over again. So as this bond is moving in this direction, and for your convenience, let me draw it like this. So what we'll get? CH3, double bond O plus phenol. So this is the overall mechanism. Fine. So what is the main reaction? Cumene process. Cumene is this isopropyl benzene, and this will be gets oxidized with the help of atmospheric oxygen and give us this. These two, acetone plus phenol. And the whole mechanism is actually involves a free radical formation, a radical formation. With the help of this atmospheric oxygen, we can actually form a radical. Then this radical gets converted into cumene hydroperoxide. Fine. This cumene hydroperoxide, with the help of the acidic H available, can form this. The plus will be acquired by this oxygen, which is not favorable. So the rearrangement takes place. This rearrangement is Hawkes rearrangement. When this rearrangement takes place, the migratory aptitude of phenyl is more than that of methyl. So it will get connected to this oxygen. And always remember, the removal of this water and migration of this phenyl will occur simultaneously. And we will get this. Then again, with a simple concept, again, this H2 will try to overcome, try to neutralize this positive charge. In the process of neutralizing this positive charge, again one H will get attracted towards these lone pairs. We'll get again the H plus Oxygen is not ready to accept the positive charge. It will donate its positive charge to this carbon and gets, gets disconnected with the whole structure. We'll get phenol out of it. As this carbon acquire a positive charge, oxygen will break this bond from hydrogen and form a double bond with this carbon. You will get acetone as well as phenol. So this is the whole scenario of the formation of cumene, formation of phenol from cumene. This is the cumene process. I hope you have an idea of cumene process in this reaction. So this is all about the preparation of phenols. In our previous lecture, we talked about this, BDC mechanism and benzene mechanism. Now today we've discussed the industrial synthesis, industrial process of formation of phenol with the help of cumene process. I hope you'll get a better idea. Thanks a lot for joining us. Please share this video and subscribe to my channel. Take care.